Question 13th. An ideal spring with spring constant K is hung from the ceiling and a block of mass capital M is attached to its lower end. The mass is released when with the spring initially unstretched. Then the maximum extension in the spring is 4 mg by k, 2 mg by k, mg by k and mg by 2k. Okay. So we have a spring, ideal spring. It is unstretched and carries some mass. Okay. Now, so it's been released. So what is going to happen? It will set itself into oscillations, right? Okay. But for maximum elongation, what do we have? Okay. For maximum elongation, we must have the velocity of the mass 0. So suppose this is my reference, okay, and I'm assuming downward positive. And suppose this is my x-axis, okay, this is my x-axis, and suppose this elongation is h. Apply work energy principle, okay, by work energy principle. Okay, what is it? Work done is equal to change in the kinetic energy. But initial kinetic energy is 0, final kinetic energy is also 0 for full stress, so W must be equal to 0, right? Okay, now what is the work done? Therefore, look, work will be done by two forces. First one will be weight, mg, and the second one is spring force, which will act upwards. Okay, mg minus kx dx equals 0. Okay, so mgh minus integral of x will be x squared by 2, so it will be kh squared by 2 equal to 0. Did you understand this part?
Yes, sir.
Okay, cancel h. So mg equals kh by 2, h will be 2 mg by k. 2 mg by k. Option B. Okay, maybe I should write a note here. When delta is maximum, that means h, okay, that delta max is spring elongation, delta is max, m is stationary. Okay, m is stationary. So change in kinetic energy will be 0 because initially it was just released. So no velocity also initially.